Hi everyone, I hope this video finds you happy and healthy. It's Miss Cronky and I'm here to talk to you today about the vertical ellipse. Hopefully you've already watched the video presented by Mrs. Homan about the horizontal ellipse, so I'll be drawing on some of the things that she talked about, so make sure you've watched that video first. Okay, so I drew actually a pretty good vertical ellipse over here on the other side. I'm pretty proud. And obviously you're going to notice that it's longer vertically than it is horizontally. So that means that we have a vertical ellipse. It's got some of the same, like I'll call them characteristics or pieces that we saw in the previous video. So it's got a center point. That's going to be our HK right there. And then it's going to have two vertices and also two minor vertices or minor endpoints. What's really important is that the vertices are on the major axis, which the major axis is always the longer axis. So in this case, it's going to be going up to a vertex and down to a vertex. So those are our two vertices, and always on the same axis as the vertices. So on the major axis will be your foci or your two focus points. So this point inside the ellipse is a focus, and this point inside the ellipse is also a focus. So those are going to be very similar to like what we had talked about in the previous video, where if you're at the center point and you go up to the vertex, that you're traveling a distance of A. So A is the distance from the center to a vertex. And if you're at the center point and you go up or down to the focus point, then you're traveling a distance of C. Okay, so C is defined as the distance from the center to the focus. Of course, we have that other distance that we travel. In the previous video, it was up and down, but now we're going left and right to our minor endpoints or minor vertex, and that is the value for B. So we're going to see and find all those same values again today. All right, so how will we know when we have a vertical ellipse? Well, we have the standard equation, and it's going to look very similar to the one we saw in the previous video. We're going to have an x minus h quantity squared. We're going to have a y minus k quantity squared. And of course, our equation has to be equal to 1. Otherwise, it's not in standard form. And these are both going to be numerators to some fraction here. And the big difference from the previous video to this video, horizontal versus vertical ellipse, is your a squared and your b squared. So previously, a squared was underneath the x minus h. Now your a squared is under y minus k, and b squared is under x minus h quantity squared. Okay, so anytime you happen across a standard form equation of the ellipse and the larger number, because remember a is greater than b, okay, the larger number sits underneath the y, then that means that it's going to be vertically oriented, have a major axis that is vertical. Oops, didn't mean to cross that out. Okay, so that's going to give me the vertical ellipse. Okay. Similarly to our previous video, c squared is equal to a squared minus b squared. So it sounds like the Pythagorean theorem, but it's not. And that's going to give us the distance to the two focus points. Oh, and also similar, I guess I should just mention, eccentricity E, the ovalness of our ellipse is determined by the ratio of C over A. So like in my ellipse that I drew over here, I mean, it's pretty oval. So my focus point is closer to the vertex than it is to the center point. And the closer you get to the vertex, the more skinny or ovally it looks. And then as you get closer and closer, if the focus points move closer to the center, then it looks more and more like a circle, more round. Okay, well, we'll just hop into some examples. So I'm going to start with x minus 3 quantity squared plus y plus 1 quantity squared all over 4 and set it equal to 1. So I'm looking at this equation, and yeah, it looks pretty much like the standard form that I had above. So I can tell that it's an ellipse. I would have to choose between my a squared and b squareds. And of course, we don't see those letters here. So the big question is, how do you know which is which? Well, this x minus 3 quantity squared is really over 1. And then remember that 0 is less than b, which is less than a. So a squared, you can also then say that 0 is less than b squared is less than a squared. So a squared is always the bigger number. So I'm going to go ahead and label this. This is a squared, and this 1 must be my b squared. So then, of course, I know that the distance from my center to my vertex is the square root of 4, which will be 2. And the distance from my center to my minor endpoints is going to be the square root of 1, which is 1. Okay. And I'll go ahead right now and I'll calculate my c squared. Okay, so c squared is a squared minus b squared. Make sure you're using the squared values there. So that's going to be 4 minus 1, which is 3. And then, of course, I have to square root that. And remember, in the previous video, we talked about we'll estimate square root of 3 like it's in between 1 and 2. It's probably like 1.7, something like that. But we'll leave it in exact form when we label the points. And then just for good measure, so I don't forget, because I always feel like I forget eccentricity, I'll go ahead and label eccentricity is c over a, so that's going to be the square root of 3 over 2. You know, the square root of 3 is actually pretty close to 2, 1.73, so this is closer to, so the focus is pretty close to each vertex. Okay, I'm going to go ahead and plot what I have. Oh, I guess I should have also named the center point, right? What's my HK? So I'm going to need that in order to be able to graph. X minus 3, that's my x minus h. So my h coordinate is 3, and then y plus 1 will give me a k of negative 1. Okay, so I'm going to sketch my ellipse. Ooh, I'm going to run out of space if I do it like that. I'm trying to think ahead. So I'll go over here. Okay, so I'm going to go right 3 and down 1. And then there's my center point. I'm going to count. So I'll use my color here. I'm going to go back to blue because this would be to my vertex. A is underneath the Y. So when I want to move A, I'm going to go up and down from my center. So I'm going to go up 2 and down 2. And those are going to be my 2 vertices. Okay. And then B is underneath the X. So X is horizontal. So I'm going to switch it over to red. And then I'm going to go back to my center and I'm going to go right 1 and left 1. And I have those 4 points on the outside, so I can draw my ellipse or my oval shape. And then the only thing I have left to do in the graph is plot my foci. So then I'm going to switch it over to green. And remember, you're just kind of estimating here. You know that the square root of 3 is more than 1, but less than 2. So we can mark it in there, somewhere right there. And I'll label it F and F. So those are my foci. Okay, let's see. I think of the things that we want to label, we have our center point. We should be able to label our vertices. So notice in the vertices that the x coordinate is going to be the same as it was for the center. So like if you're going back to the origin, Right here, you're counting 1, 2, 3 to the right. And then to get to my vertex at the top, I would go up 1. So 3, 1. And go back to the origin. I'm going to count 1, 2, 3 to the right, and then I'm going down 3. So 3, -3. Let's see, my foci are on the same vertical axis or major axis as the vertices. So same thing, the x for the foci is also going to be 3 because it's on the same vertical line as the center and the 2 vertices. So it's going to be my y that would change instead of being at -1, like for my center point right here. I'm going to be adding and subtracting a square root of 3. So one of my focus points is at -1 plus the square root of 3, and the other is at -1 minus the square root of 3. And in this case, I'd be okay with you writing -1 plus or minus the square root of 3. So there's really 2 foci right there. Okay. Let's see. So I've got that. I've got eccentricity listed. I've got the center, vertices, foci. And if you wanted to, or if you had knowledge of the minor vertices, you certainly, or minor endpoints, you certainly could figure out those ordered pairs. Now your x is going to change from your center. You're going left 1 and right 1. So we're at 2, -1. And we're at 4, -1. Okay, and so there we have a vertical ellipse. I'm going to do another example. I'm going to change it up a little bit here in this example. I'm going to make it 12 times the quantity x plus 2 squared plus 4y squared equals 48. And you're looking at that equation. And you might be tempted to see it almost like a circle because it's not equal to 1, but it can't be a circle because the coefficient to x squared and y squared aren't equal. Like if I were to divide both sides by 12, I wouldn't get a 1x squared and a 1y squared. So when the coefficients in front of x squared and y squared are not the same, then it must be an ellipse and not a circle if they're being added together. So what we want to do in this case is it's not in standard form until this other side is equal to 1. So when we're looking at this 48 over here, how can we get that to be equal to 1? Oops, didn't mean to highlight there. How can we get that to be equal to 1? Well, we'll just divide by 48. Because then it will be equal to 1. That means I have to divide each term on the other side by 48. And so I come up with something like this. X plus 2 quantity squared over 4 plus y squared over 12 equals 1. Okay. And I can go through and I can label the things that I need. So my center point is at -2, 0 here. I can determine that my a squared is 12. So then a is the square root of 12, which is 2 square root 3. I know that b squared is 4, so b is 2. And that makes sense because it's less than the 2 times the square root of 3. I can find my c squared, so I'll do that up here. C squared equals, remember, go back to the squareds, a squared minus b squared. So c squared is equal to 8. Square root, c is 2 square root 2. And then I can draw my ellipse. So I'm going to go left 2, and up or down 0. There's my center point. If you want to label it with the C so you can keep track of everything, go ahead and do that. I'm going to move with my A, which, you know, for like 2 square root 3, I think it's probably easier on the graph to think about like the square root of 12. Well, the square root of 12 is in between the square root of 9 and the square root of 16, so it's probably like a little bit less than 3.5. So I'm going to count up 1, 2, 3, and a little bit more. And I'm going to count down 1, 2, 3, and a little bit more to get to my vertices. And remember, I know to count up and down because this a squared is with y. So that's telling me where my major axis is. When I'm plotting my b, or moving distance of b, that's underneath x. So I'm going to go back to my center and I'm going to move horizontally 2 to the right and 2 to the left. And then I can draw my ellipse. Okay. Also, I should always make sure in my picture that I have plotted my foci, and 2 square root 2 or the square root of 8, that's just under 3. So go back to your center point and count up just under 3. So there's going to be a focus. And here is another focus point. So we can go through and we can label things. I'll go a little bit quicker here. Let's see, I'm going to do eccentricity right away. That's C 2 square root 2 over A, which is 2 square root 3. Well, this is a good one. It reduces square root 2 over square root 3. Got to rationalize that, multiply by the square root of 3 on the top and the bottom. So my eccentricity is square root 6 over 3. Let's see, my vertices are at -2, and then my y value was at 0, but I went up 2 square root 3 and then down 2 square root 3. So in this case, since I'm going from 0, I can write that as plus or minus 2 square root 3. And that'll get me 2 points for my vertices. My foci, again, I'm going from my center at -2, 0, and I'm going up 2 square root 2 and down 2 square root 2. So I could say from -2 for my x, and then plus or minus 2 square root 2. Okay. And then if you wanted to list your minor endpoints or minor vertices, we can easily identify those because we just counted 2 left and right from -2. So we're at -4, 0, and 0, 0, the origin. Okay. All right, so I've got one more problem for you. You can probably guess what kind of problem we're going to do next. It's one of those where we need to complete the square. So I've got 9x squared plus 8y squared plus 36x plus 96y plus 252 equals 0. And I'm going to do this just a little bit different so you can kind of like compare how you saw it in Mrs. Homan's video and then how I do it here, just because there's a lot of terms over here, and I know I'm going to be completing the square because I have the x squared and the y squared. And I can tell this is an ellipse, not a circle, because they don't have the same coefficients again, similar to the previous problem. But I'm going to move this 252 to the other side because that's that constant term that we're always like adding or subtracting from. Really, it's like subtracting the thing that completes the square. But I'm going to move it to the other side, and you can decide like which method you like. So I'm doing it a little bit different. Okay. Okay, so I'm going to rearrange it. So I have 9x squared plus 36x. I'm going to regroup my letters. And then I'm going to have a plus 8y squared plus 96y. And then I'm going to leave some room because I'm going to be completing the square. But I'm going to move the 252 to the other side. Okay. So now I want to complete the square, but before I do that, I have to factor out the thing that's in front. And remember, you're completing the square for that perfect square trinomial. It's going to be included in that set of parentheses, so we'll have to redistribute the thing we factored out. And let's see, 96 divided by 8 is 12. and it's going to be equal to negative 252. And now I can start doing the work to complete the square. So looking at the x squared plus 4x, take half of 4 and square it. That's going to be a plus 4. Of course, what I really did right there was 9 times 4, which was plus 36. So like normally if we had left 252 on the left, we would then subtract 36 because we're trying to keep the balance of the equation. But what I'm going to do is I'm going to say, since I moved the 252 to the other side and I'm negative 252 over there, I can do the same thing to both sides of my equation. So I'm going to add 36, and then I'm going to complete the square again for y. So half of 12 is 6, squared is 36. So I'm going to put a plus 36 in there. And then what I really did was whatever 8 times 36 is, I really added a 288 right there. And if we're doing it the old method, we would subtract 288 from the same side. But since I've moved those numbers over to the other side, I can also do a plus 288. So if you like that method where you're like doing things to both sides, or the same thing to both sides, you can do it that way too. So that's just basic algebra. Okay, so now I'm going to clean this up. I've got that 9 coefficient. I've got the x plus 2 quantity squared, and then plus 8 times y plus 6 quantity squared. And then over here, I just have to combine those numbers. Let's see, I get equals 72. And then this looks very similar to the previous example that I just did. It's not quite an ellipse yet, and don't be confused and think that it's a circle because it still doesn't have matching coefficients for x and y, or the x squared and the y squared. So what I want to do is divide both sides by 72. Okay, so each term is going to get divided by 72. And that's going to leave me with x plus 2 quantity squared over 8 plus y plus 6 quantity squared over 9 equal to 1. Okay. And if I were looking at this standard form equation, I could tell that this is a vertical ellipse just by looking at those denominators. Since the larger number 9 is underneath the y squared, I'm going to be going up and down to my vertex points, and it will create a vertical ellipse. My foci will also move up and down because A and C, vertex and foci or focus, are always on the same axis, and then I'll count left and right to move to my minor endpoints. Okay. Make sure that you do the homework and email us or visit us during office hours if you have questions. Really important that you're getting these things answered before we get assessed on this material. So let us know if you have questions, and have a great day.